Thank you so much. Good afternoon, good evening, and good morning, everybody, depending on your location. Thanks very much for joining us, and welcome to the inaugural BioIT World Web Symposium. I'm Kevin Davis, the founding editor of BioIT World, and we are tremendously excited to be kicking off a new series of web symposia today with the very timely and important topic of next-generation sequencing, storage, and IT. Before I introduce our three speakers, a quick word of thanks to our sister company, Barnet Educational Services, and particularly Barbara Potter, who you just heard from, for their help on the technical and logistical side, without which we wouldn't have gotten this far. And we also must immediately thank BlueArc for underwriting today's webcast so that we were able to offer free complimentary registration to everybody on the line. We're going to try and keep today's web symposium to 90 minutes, and as Barbara mentioned, we'll take questions at the end of each talk, so you're welcome to enter questions live in real time during the presentations, and then we'll squeeze in as many as we can, and if the speakers are still around at the very end of the symposium and there are still things we'd like to discuss, we'll try and get to that as well. I really can't think of a more appropriate topic to kick off this series than the myriad issues produced by the generation and handling of next-generation sequencing data, and obviously in 90 minutes we can only begin to scratch at the surface of those in a symposium such as this, but we hope that today's session will prove informative, and I can guarantee you that we'll be revisiting this subject from many different angles in the months to come as we launch additional symposia, and your feedback on what we should be doing will be very welcome in that regard. So our three speakers today are Lincoln Stein from the Ontario Institute for Cancer Research. He'll be speaking second. James Reaney from BlueArc will round off the trio. But leading us off, I am delighted to welcome and introduce Melissa Kramer from Cold Spring Harbor Laboratory on Long Island, New York. Melissa is a scientific informatics analyst working in the team headed by Dick McCombie, and McCombie learned his sequencing chops 20 years ago, I think it was, with Craig Venter. So this lab really has a tremendously rich pedigree, really one of the first labs to begin automated DNA sequencing. The operation Melissa is about to describe for you may not quite match in terms of raw scale and throughput the major genome centers, but I think her experience in managing the tremendous growth of this particular sequencing facility and the challenges that her team have faced during that process will hopefully be extremely relevant to you, whatever the size of your current or potential sequencing operation. Melissa, thank you again very much for joining us, and over to you.
Thank you very much, Kevin, for the kind introduction. Again, my name is Melissa Kramer, and I am in the bioinformatics group in Dick McCombie's lab at Cold Spring Harbor. I manage the next-generation sequencing data on a daily basis for our lab, and I'd just like to give a brief overview of some of the projects that we're doing in our lab, as well as some of the challenges that we faced in implementing the next-gen sequencing processes. The massively parallel sequencing technologies have dramatically reduced the cost and increased the speed at which we can sequence large, complex genomes. If you think of the first human genome sequence completed in 2003, it took approximately 5 years and $300 million to sequence.